Hello everyone. Today I am excited to show you how function agents work in this framework I have built for creating AI agents on the Salesforce platform. The framework also supports two other agent types, conversational agents and workflow agents, but I will save those for future videos. Function agents are smart automation that can analyze data, make decisions, and take actions, all guided by natural language instructions rather than hard-coded logic. Today we will walk through three examples showing increasing complexity from simple summarization to sophisticated multi-step orchestration. But before we dive deep into the demos, I want to make sure everyone understands the foundation, function calling, and how LLMs can intelligently use tools. Feel free to pause the video here and read through what's on the screen. It will give you the context you need for the demos. Alright, now that you understand how LLMs can intelligently call functions, or as we call them in this framework, capabilities, let's see it in action. Quick note, before we start, I should mention I am using GPT-4o Mini for this demo, one of the most cost-effective models, but honestly not the smartest. Some might even call it lazy compared to flagship models like GPT-4, 5 or Claude Sonnet. If GPT-4o Mini can orchestrate multi-step campaigns with conditional approvals and error recovery, you can be confident the framework is robust. Alright, let's dive in. Let me start with the simplest example, a case summary agent. Here's the agent configuration. The instructions tell the LLM what to do. Notice this agent has no capabilities. It doesn't call any functions. It simply applies LLM intelligence to the case data that's loaded into its context via the case context provider, which includes case details, account information, activities, and history. Here's a support case about a data integration failure affecting 200 users. Let's run the agent. I will click on Summarize Case Quick Action. And there's our summary. One LLM call, one response. Pure intelligence applied to structured data. Now here's an important point. For simple use cases like this, you really don't need a framework. A basic Apex callout is sufficient. But when you need dynamic function calling, multi-step orchestration, error recovery, human approvals, or execution debugging, that's when a framework becomes invaluable. Let's see that next. Now let's see function calling in action with an account fit scoring agent. This agent scores how well an account fits our ideal customer profile for a product launch. These are the agent instructions. This agent has a capability it can invoke. Score account fit. The agent reads account data from context, calls the function with the necessary parameters, gets the score back and returns the result. Let me show you what a capability looks like. This is a custom record page I built for configuring capabilities with a better UX experience. Every capability has a name and description that the LLM reads when deciding which function to call. LLMs are trained on Markdown and understand it very well, which is why I built a Markdown editor component. The implementation type can be standard, Apex, or flow. In this case, it's a flow. The key parts are parameters, which means what inputs the LLM needs to provide when calling the function. For this capability, we have 4 required parameters that the LLM needs to extract from context: account ID, industry, employee count, and annual revenue. I have built custom components so you don't have to write raw JSON, though you can use the JSON editor for advanced configurations if needed. Here's Start Go Labs. 8 employees, 500K annual revenue, an early stage startup. Let's see how the agent scores it. The agent scored this account at 70 by 100 with a good fit level. Now let's look at what happened under the hood when I executed this agent. This is the first time you are seeing our storyboard component. It visualizes the entire agent execution flow. This is where the storyboard really shines. Let me walk you through it. First, the user input. Next, static configuration shows everything the framework prepared before making the LLM call. It has three tabs. Context, the account context provider loaded account details, opportunities, activities, and contacts. System prompt, the agent instructions and execution context. And tools, available tools with their parameter definitions. The LLM request section shows the actual request made to the LLM, combining the system prompt, context data, available tools, and user message. The LLM response shows the LLM's decision to call the score account fit tool. Notice it intelligently selected the correct tool. Well, there was only one tool configured, so I won't say intelligently selected, but it definitely intelligently extracted all four required parameters from the context data: account ID, industry, employee count, and annual revenue. Finally, the tool response shows the framework executed the score account fit flow and received the score 70, fit level good, and reasoning. That's the complete execution flow visualized step by step. The storyboard makes it easy to debug and understand exactly what happened, what data was loaded, what the LLM saw, what it decided to do, and what results it got back. Now for the main event, Product Launch Orchestrator. In the previous demos, we saw agents with 0 or 1 capability. This agent has multiple capabilities and needs to orchestrate them intelligently to accomplish a complex business workflow. The use case is building an account-based marketing campaign for a product launch. The agent handles everything: qualifying prospects, personalizing outreach, creating campaigns, assigning tasks with approval logic for high-value accounts, and logging insights. Let me show you the agent configuration. These are the agent's instructions. Notice the instructions clearly specify the qualification threshold at score 50 or higher, the approval logic with revenue over 50 million threshold, and what to do on rejection. Escalate and stop. The LLM reads these natural language instructions and orchestrates the workflow accordingly with no hard-coded flow definitions. Let's see it in action. Let me run the agent for Tech Corp Innovations. I will use Apex API to execute the agent, though you could also invoke this from a flow, a trigger, or a lightning component. All right, execution completed. Let me show you the key outcomes. It's still running. Let me refresh this component. All right, execution completed. Let me show you the key outcome. I will scroll through quickly. Perfect 100 by 100 score, hot engagement, generated a personalized message referencing their specific pain points, created the campaign and added them as a member, assigned follow-up task, no approval needed since revenue is 25 million, below the threshold, and finally logged insights to the team. Perfect. 5 steps fully orchestrated by the agent following those natural language instructions, all done automatically. Let's try a different scenario, an account that doesn't fit our criteria. Megacorp Global Industries. 5,000 employees, 500 million revenue, manufacturing industry. This is deliberately a poor fit, way too large for our mid-market target, wrong industry, and cold engagement with no buying signals. Let's see if the agent excludes it. All right, execution completed. Let me show you what happened. The agent scored Megacorp at 40 by 100 below our 50 threshold, and here its reasoning. Given the account's low fit score and moderate engagement signals, it is advisable to exclude Megacorp Global Industries from the targeted ABM campaign. This is intelligent filtering in action. The agent evaluated the account, saw the low score, and immediately stopped. No wasted effort on messages, campaigns, or tasks for a poor fit prospect. Now let's look at the human in the loop approval feature. Enterprise Giant Corporation is a technology company. This is a perfect fit. Technology industry, mid-market size, excellent revenue. But notice the revenue, 75 million, which exceeds the 50 million threshold. Our agent instructions say accounts with revenue over 50 million require executive approval before assigning tasks. Since 75 million is greater than 50 million, this should trigger the approval requirement. Let's see how the agent handles this. All right, let's open our storyboard component. It's still working, so we will refresh this component. It's saying awaiting action. Let me show you what happened so far. The agent first qualified the account, scoring 100 by 100 with engagement level hot, deciding to include it in the campaign. It created the campaign and added Enterprise Giant as a member. The agent tried to call assign sales task and paused for approval. Here's the approval request. Now let me approve this request. Before we dive into what happened, notice the cost displayed at the top of the storyboard. This entire execution, qualifying the account, generating a personalized message, creating the campaign, waiting for approval, assigning the task, and logging insights, cost less than a cent using GPT-4o Mini. That's right, fractions of a penny for a complete multi-step workflow. This is the power of using cost-effective models for broad workflows. Now let me approve the request. Now it's processing. I will wait for the execution to complete. Let me scroll down. The request was approved. The agent executed the assigned sales task and logged campaign insights with a summary showing the campaign was created for one qualified account. Excellent. This demonstrates LLM-driven conditional HITL. Now let's see what happens when an approver rejects a request. So I will again execute the same script. There will be a second agent execution record. Sorry, this is the old one. Awaiting action. Let me scroll down. This time I will reject the request. Now I will wait for the execution to resume and complete. The status is now completed. Let me show you what happened. After the rejection, the agent created an escalation case by calling create escalation case tool with subject executive review required with a description linking the same account ID with priority as high. And then it stopped execution. It did not call log campaign insights as per the instruction, completing the execution without logging insights. This demonstrates intelligent rejection handling. The agent recognized rejection as a workflow blocker. The key difference from the approval is that approved requests proceed to task assignment, then insights logging and complete, while rejected requests create an escalation case, then stops with no insights. This shows sophisticated workflow branching based on human decisions, all driven by natural language instructions. Now for the final feature, error recovery and resume. Let me show you how the agent handles failures and resumes from the failure point. Now let me intentionally break something to show how error recovery works. So I will go to AI agent config page, check for one of the capabilities, generate campaign message, and I will make some change in the JSON editor. Make it invalid operation. Click on save. Now let's run the agent for one of the accounts. So I will use tech corp. Looks like execution has started. Now I will visit the account record page. May refresh. Okay, I can see the recent execution with the status as failed. I will go to storyboard component. Let me scroll down. You will see that when it executed generate campaign message and it got an error. After this, the framework sent those error details to LLM. LLM again decided to run the same exact tool. It failed again because the capability is not configured properly. We have set the maximum retry limit as 2, because of which it didn't execute any further and the execution have stopped. So as expected, the agent failed. If I try to resume the execution, okay, function resumed, but it was still not able to execute the tool without any errors. So now let me fix the capability. We go to agent capabilities, generate campaign message, JSON editor, and generate message, click save. Now let me resume from the failure point. Now the status is showing as processing. Let me refresh this component. It's still processing. The status is showing as completed. Let me scroll down. You will see when I resume the function for the second time, it was able to successfully execute the tool, generate campaign message, and after that it was able to create campaign members, assign sales task, log the campaign insight. This is error recovery and resume in action. The framework tracked which steps were completed, identified the failure point, resumed from that exact point, and avoided re-executing successful steps. This is critical for complex workflows with multiple steps. If an agent execution fails midway through a multi-step process, you don't want to start over. You want to pick up where it left off. That's exactly what this framework provides. Alright, that was a comprehensive tour of function agents. If you made it this far, you are either genuinely interested or you fell asleep with autoplay on. Either way, thank you. What's next? I am currently working on 3 additional features. PIA masking, which is automatically detect and mask sensitive data like SSN, credit cards, etc. before sending to LLM provider. Second is prompt safety. And the third is policy-based governance. I'm still researching. It's like a runtime validation to ensure agents stay within defined boundaries while maintaining flexibility. Think of it like a referee in a game. Players have freedom to make decisions, but there are rules that cannot be broken. In my next video, I will show you workflow agents. These are designed for complex multi-stage business processes that need state management across multiple sessions, parallel branching workflows, complex approval chains, and integration with external systems. Think about scenarios like loan approval process, customer onboarding workflows, multi-department case routing, and similar scenarios. If you are interested in this framework, I encourage you to test it out. Give us a star on GitHub to help others discover the project, and we welcome feedback and share your use cases, as I would love to hear what you are building. You can find the GitHub repo at iamsonal/AI Agent Studio. I have also provided documentation. You can check the documentation here. Thank you for watching. If you have questions, drop them in the comments. See you in the next video.